So to estimate the limit as x approaches 3 given this equation, we can draw in our given epsilon, which is 0.5, away from our point of interest, which falls at 0.4, where it intersects our graph. So we can go 0.5 units and 0.5 units above and below. So this gives us an error band at 4.5 and 3.5. And finding where these lines intersect with our graph, we can estimate that where it intersects at 4.5, it falls at about 2.7, and at the 3.5 line, it falls at about 3.2. And this will give us a delta value of 0.2, as is the distance. The maximum distance it is allowed to be away from 3 and still be in our error band. And to find this graphically, we can graph the lines 4.5 and 3.5, which are our limit plus and minus the epsilon, and then we can find the actual intersection between these lines and our graph. So the intersection between 4.5 and our graph has x being 2.7071, and the intersection between the line 3.5 and the graph is 3.2614, and this gives us our delta distance of 0.2614 units away from 3. And now to find this algebraically, we can take the graph as it approaches from the left side, and since it intersects with the 4.5 line, we can set this portion of the graph equal to 4.5. And this is the quadratic equation. So we can add 4.5 or subtract 4.5 by both sides, run the quadratic formula, and that'll give us an answer of x being 2.7071, which matches how we found it graphically. And now as it approaches from the right, it intersects with the 3.5 line, so we can set this portion of the equation equal to 3.5. And to do this, we can divide 4 by both sides, and to get rid of the exponent, we can take the log of 0.6 of both sides, and then we simply add 3, and this gives us an x value of 3.2614, which matches how we solve for it graphically. And again, our delta is 0.2614, and this fits the bill of a limit because our given epsilon is a positive number, and our delta is also a positive non-zero number, and x does not equal c in both cases. And so that's how we solve it.